In the energy supply system, the thermal power industry shoulders the dual responsibility of power generation and heating. The stable operation of its entire process cannot be achieved without the support of an efficient and reliable dust removal system. And the pulse valve is the power core of the dust removal system. The dust removal requirements of the thermal power industry can accurately correspond to the four core process segments: raw material storage yard, belt conveying, boiler power generation, and slag transfer. The dust characteristics of each process section are different, so the adaptability requirements for pulse valves also have their own emphasis. Firstly, let's take a look at the process section of the raw material storage yard. This is the first gateway for coal and other raw materials to enter the thermoelectric system, including key processes such as raw material crushing, open yard storage, and material transfer. A large amount of coal dust will be generated during the crushing process. Wind-induced dust in the open yard. Wind-induced dust in the open yard. Dust diffusion during material transportation and unloading. Not only does it pollute the working environment, but it also causes material loss. At this point, it is necessary to equip dust collector equipment to capture and treat the dust. The pulse valve is responsible for driving the dust cleaning action for the dust filter bag. Ensure the continuous and efficient operation of the dust collection system. Next is the belt conveying process section. The fuel transportation of the thermoelectric system relies on multiple belt conveyors, and the impact of material falling at the unloading transfer nodes of each transfer station can cause severe dust. The dust concentration in such scenarios is relatively moderate, but the number of transfer points is large and widely distributed. The suitable dust collection equipment is mostly small and medium-sized bag filters. Therefore, more small-sized pulse valves will be used to meet the cleaning needs of high frequency and small airflow. Ensure that the dust at each transfer node can be effectively controlled. Moving on to the boiler power generation process section. This is the core segment of thermoelectric production. The flue gas generated by boiler combustion contains a large amount of pollutants such as smoke, dust, sulfides, etc. It is the top priority for dust control in the thermal power industry. The dust removal in this process section is mainly based on dry dust removal technology, including ESB, and bag filter composite dust collector. For the flue gas after wet desulfurization, there is also a wet ESB used for deep purification. Pulse valve as a key component of the dust cleaning system directly determines the purification efficiency of the dust collector. Its stable operation can effectively avoid filter bag blockage and ensure the standard emission of boiler flue gas. Finally, there is the slag transfer process section. The slag after boiler combustion needs to be transported by a belt conveyor to the slag yard for stacking or further utilization. At the transfer junction of the slag dropping point, high-temperature dust and particulates will diffuse synchronously. The dust removal requirements in this stage are similar to those in the belt conveying process section. Driving dust cleaning through a pulse valve can prevent dust from easily dispersing and maintain a clean factory environment. There are two key considerations when selecting pulse valves for special operating conditions in the thermal power industry. One is the explosion-proof requirement. In flammable and explosive scenarios such as coal powder dust removal, it is necessary to select sealed, explosion isolation, or explosion isolation sealed pulse valves according to the on-site explosion-proof level. Eliminate safety hazards from the route and ensure production safety. The second is size selection. Dust collectors in the thermal power industry generally have the characteristics of high air volume and large filter area. The external dimensions of the equipment are large floor space. Therefore, in core scenarios such as boiler flue gas dust collection, 3-inch, 3.5-inch, and 4-inch large diameter pulse valves are preferred. Meet the demand for high airflow pulse cleaning. And in scenarios such as belt conveying and slag conveying, small pulse valves are often used to achieve fine dust cleaning. From raw material entry to waste disposal conveying, from flue gas purification to environmental supply assurance, pulse valves play an indispensable role in dust collection systems throughout the entire process of the thermoelectric industry. Choosing the correct pulse valve and using it well can not only help thermal power enterprises achieve dust emission standards, but also ensure the stable and efficient operation of the production system. Building a solid environmental defense line to ensure energy supply.